Today we are going to learn a new method for numerical integration, and that is Simpson's 1/3 rule. Let's consider the function which we are going to integrate as y. So I am going to integrate y integral from x0 to say xn. Okay. To understand how we do it numerically, let's first draw the function y. So assume a function. I am going to draw it. Let this be the function which we consider. Okay. Now you know that this is the function. So this is the function at the point, value of the function at the point, say x0, and this is the value of the function at the point xn. Okay, so let me call the value of the function at the point x0, that is its value, as y0, and the value of the function, that is here, value of the function at the point xn, let this be yn. Okay, so now you remember what you did in the numerical integration by trapezoidal rule. So there what we did was we assumed, instead of the function, a straight line from y0 to yn. And then we, assuming a straight line between y0 and yn, you integrated the function, or you added the area under the curve, approximating this function as a straight line or a first order polynomial. And that was what was done in the trapezoidal rule. Now, Simpson's 1/3 rule is a still different kind of an approximation, or you can say it is a little more better approximation. So here what it is done is you consider a point midway between x0 and xn. So let me consider the point midway between x0 and xn as here. So the value of the function will be, or value of the point will be, x0 plus xn by 2. This is the midpoint of x0 and xn. Now the value of the function at the point x0 plus xn, that is this. Okay. So now approximation in Simpson's 1/3 rule is you approximate this function as a second order polynomial which passes through the point x0, which passes through this point, that is y0, passes through this point and this point yn. Okay, so let's assume, okay, anyway, so considering an approximate second order polynomial which passes through y0, then this point and yn, you are proceeding the integration. Okay, so last time when we approximated this function as a straight line, we finally reached at the trapezoidal method for integration. Here, by assuming a second order polynomial which passes through the point y0 and this point and then yn, you do the integration. Okay, so basically what is happening is that when we assume a function or a second order polynomial which passes through this and this, I can say that the value of the assumed function of a second order polynomial at the point x0 is y0 itself. Okay, at the point say x0 plus xn is the value of our original function itself. Okay, and the value of the second order polynomial at the point xn is yn itself. So the values of the assumed polynomial at the point this and this is the exact function or is the value of the exact function which we have. So based on that we try to approximate the second order polynomial. Okay. Now you just think that let us consider second order polynomial. So let me write this as a0 plus a1x plus a2x square. Okay. So this is then assumed, let's say this is the assumed second order polynomial passing through these points. So when it passes through this point, I know that x is, so when the polynomial passes through this particular point, say x0, I can find out, so at that time x is actually x0, and here also you can substitute for x0. So you can have one equation when the value of x is substituted as x0. Okay. Then you can have next equation where the value of the x is substituted as x0 plus xn by 2. Then also you have a function like this. Okay. Then also putting the value of x as x0 plus xn by 2, you can have another set of value for or equation for a0 plus a1x plus a2x square. You can have 0. Now again, assuming the value for xn, x as xn, again you have another set of equation. So we can get three sets of equations for this second order polynomial which we have assumed, considering one value of x as x0, another value of x as x0 plus xn by 2, another value of x as xn. Okay, so using these three sets of equations, these three sets of equation, you can basically find out the value for a0, a1 and a2. That is, I can say that integral of y dx can approximated as x0 xn. Y now we have approximated as a0. That is what is done in the Simpson's 1 by 3. We approximate the function as the second order polynomial a0 plus a1x plus a2 x square. Then as I said before, putting the value for we have to, if we want to solve this polynomial, what we have to do, or if we have to find the integral, what we have to find a0, a1 and a2, right? So solving the equation at the 3 points of x, you can find out, or getting three equations for 3 values of x, you can find out the value of a0, a1 and a2. That is 3 equations and 3 unknown. You can find out a0, a1 and a2. And then this a0, a1 and a2 values you can put in this integral, and finally you can arrive at a particular equation for integrating, and that is actually the Simpson's 1 by 3 rule. So I said this much to basically understand what is happening behind a Simpson's 1 by 3 rule of integration. Now finally when you put all these a0, a1, a2 values substituted and finally solving, so it does have a number of numerical steps has to be followed finally before getting the final expression, and I'm not going into that details, just understand what is happening in the Simpson's 1 by 3 rule, and finally we end up the equation formula as, that is integral x0 to xn, value of the function y dx under Simpson's 1 by 3 rule can be written as h by 3 y0 plus 4 times y1 plus y3, all the odd functions, that is y5, like that it goes, plus 2 into y2 plus y4 plus all the even integer. So the last term here is plus yn minus 1, and here the last term is plus yn minus 2, then plus yn. Okay, so this is the Simpson's 1 by 3 rule here. Integral of the function y dx over x0 to xn is h by 3, and you remember h is basically the interval which you take between these. So x0 is x1, suppose it is divided into 2, and what is the interval we are dividing x0 to xn? So let it be, so suppose you consider x0 is 1 0 and xn is 1, and you are dividing it in at the interval 0.5. Okay, so that is you have only two, basically 2 units, or I can say you divide the whole function into 2 intervals. So that means your h is actually 0.5 there. So that is the interval is actually the h, or the small units, or the separation between the between the values is actually called as the h here, or you can say that it has the width of the interval. Okay, so that is the h, and y0 is the value of the function at the point x0, and then y0 plus 4 times all the values of the functions at the odd intervals. Okay, then the 2 times the values of the function at the even intervals, and then plus last value yn. So this is how Simpson's 1 by 3 rule method should be used, or this formula is used to integrate a function, or integrate an integral with the limit. Okay, so this is the formula, but you have to keep in here mind is that in the Simpson's 1 by 3 rule, we call it as 1 by 3 rule because you have a 1 by 3 a fraction of 1 by 3 in the formula. That is why it is called as the 1 by 3 rule. And the one thing which we have to keep in mind is that we have to divide the whole range into an even number of intervals. Okay, here we divide the whole thing. Here as I have drawn here, basically the function or the whole interval was divided into 2 units, right? So similarly you can have small, suppose I have a function, or you can say x0 to xn, x0 plus xn by 2 again can be divided into 1 unit. So here again the division, basically I can say that the whole function should be, or the whole interval has to be divided into even number of subintervals. That you have to keep in mind. You can divide it into 2, then you can divide it into 4, then you can divide it into 6, like that it has to be divided. So that should always be kept in mind, that you can understand. If you have understood the Simpson's 1 by 3 rule, you basically can understand why it is being divided into even numbered intervals. Okay, hope this is the 1 by 3 rule of Simpson's integration method. If you have any queries, please put it in the comment box. Thank you.